Hello, so in this video I'm going to review the 6 steps of a derivation with reference now to indirect derivation, and then I'll do a couple of indirect derivation examples. So, first step is the same, show the conclusion. Second step is different. You now always want to make an assumption. If you can, do assume CD. If you're trying to show a conditional, assume CD. That hasn't changed. But you can now do assume ID in any other case. Assume ID lets you assume the negation of the conclusion, and the conclusion always does have a negation. If the premises are true, the negation of the conclusion is false, but the sentence exists. And so you can always make an indirect assumption, and that means you can always make an assumption. Conditional if you're trying to show a conditional, negation if you're trying to do an indirect otherwise. Now, that means you could have done an indirect assumption in all of the previous derivations we've done. It wasn't necessary in any of them, obviously, and so, because you didn't do them, but, and that means that going forward, you're always going to be in a situation where you could make an indirect assumption, and it might not be necessary. And making it could make your derivation a little bit longer. It's going to add a line, and it might make it a little bit more confusing. You have more to work with. On the other hand, you might need the indirect assumption. So I would go ahead and make it automatically now, knowing that I may not need this. But again, remember, if you can, you prefer to make the assume CD. You only do assume ID if you can't. And then we proceed as usual. So we enter our premises. We apply our inference rules, knowing that we prefer elimination rules. If we get stuck, if the derivation gets stuck, we do a subderivation. And when we do a subderivation, we might do assume ID as an assumption there. And then we box and cancel. But now we need to remember there are more options for boxing and canceling. We have DD, which is the conclusion, CD, which is the consequent of the conclusion, or ID, which is any contradiction. And that you have to pay attention for. You have to look for those ID opportunities, those contradictions. Previously, when you look at the show line, you know, okay, I'm going to get the show line, the conclusion, or I'm going to get either the show line or its consequent because it's a conditional. Now you know, I don't know, any contradiction might do, and you don't know what the contradiction is going to involve, so you have to keep your eyes open and be looking for that contradiction. Okay, so let's take a look at some examples with indirect derivation. So we're going to do some example derivations, some example indirect derivations, and we'll start with some pretty straightforward ones. So our first step of our 6 steps is always to show the conclusion, so we'll do that. Our second step is to always make an assumption. That's new. Previously we would make an assumption when we were showing a conditional, because we could do assume CD, but otherwise we would not make an assumption. Now we can always make an assumption because we can always do assume CD or assume ID. And the rule, what you want to do strategically is you always, if you can, do assume CD and then do assume ID otherwise. And you may need to make that assume ID, you may not need to. You've seen lots of derivations with no assumptions, but from now on you want to be thinking, I always want to make an assumption. If I can, I'm going to make a conditional assumption, otherwise I'll make an indirect assumption, which I can always do. So in this case, we look at our conclusion on the show line, and its negation of P and Q. That is not a conditional, so we cannot make a conditional assumption, so we'll do assume ID instead. And that will give us P and Q. Now let's bring in our premise. Okay, so we have P and Q on line 2, not P on line 3, so we did our show. We made an assumption, we brought in all the premises, in this case just being 1, and now we're going to use our inference rules to hopefully get to the point where we can box and cancel. So since we started with assume ID, we probably want to be looking for a contradiction so that we can box and cancel with ID. So that's where we're sort of thinking, and with that goal in mind, let's go ahead and apply our inference rules. So we always want to use our rules that break up stuff, so we can break up 2 using simplification, so we can say 2SL and 2SR, and now we want to look and see, okay, do we have a contradiction? And in fact we do. We have a contradiction on lines 3 and 4. And so we can say indirect derivation. So there we go. And this, I hope, makes sense. The premise says, is P true? No. And the conclusion says, is P and Q true? No, it says the conjunction is false. And if P is false, then the left conjunct is false. So the conjunction is false. So the negation of the conjunct is true. So yes, we can get from negation P to negation of P and negation of P and Q. Note that if our conclusion was this, we couldn't get to line 9. Line 9 says, here are 2 things. my left conjunct is true, which is negation P, and my right conjunct is true, which is negation Q. So I, line 9, say that both P and Q are false. Whereas this, this actually, line 8, doesn't say that both P and Q are false. It says that the conjunction of P and Q is false, and there are many ways that the conjunction could be false. P could be true and Q could be false, Q could be false, or P could be false and Q could be true, or both P and Q could be false. They would, in any of those situations, line 8 is true. So line 8 effectively says either P is false or Q is false. So okay, that's why this is a good valid derivation. We say assume ID, we bring in our premise, we break up line 2, and we find our contradictions with lines 3 and 4. We didn't need to do line 5. So there is our first derivation. So let's go ahead and take a look at another one. So, and we'll say show conclusion. Here we're trying to show the negation of a conditional. It's not the case that if P then Q. And again, if we don't make an indirect assumption, we're getting nowhere. So we do need to make an assumption. And we can choose either one. Let's choose the unnegated one, or the undouble negated one, the one that is the unnegation of the conclusion. Now this is going to be straightforward. We have we actually can do two things with 2. We can do 2, 3 MP. We also do 2, 4 MT. And again, we get lots of contradictions. In a direct derivation, if you were able to do modus tollens with, or modus ponens, say, with line 2, you wouldn't also be able to do modus tollens. But here, because of 3 and 4, you could do MP and MT. When you're in a situation where you can do MP and MT, you're going to get a contradiction. And again, you don't actually need to do both of them because we have a contradiction on lines 4 and 5. So 4, 5, ID. Good. Okay, so this is the last problem that we'll do in this video, and then there'll be some more examples of somewhat more complex problems in the next video. But we'll finish with this problem in this video. And this problem is basically the converse of the previous problem. In the previous problem, we said, suppose that P is true and also that not Q is true, and we argued that the conditional if P then Q is false. And we're basically going in the other direction in this, this problem. We're going from the conditional to saying that a conjunction is false. So our conclusion is negation of P and Q, so that's our first step. Our second step is to make an assumption, conditional if we can, indirect if we cannot. We cannot make a conditional assumption, so we will make an indirect assumption giving us P and Q. We'll go ahead and bring in our one premise. Okay, so we want to apply our inference rules now at step 3. Step 4. Show the conclusion, make the assumption, bring in the premises. Step 4. Do our inference rules. So with 3, we would need P or negation of negation, Q for MP or MT, neither of which we have, but we can split up 2 again. And we get P and we get Q. And at this point, we have 2 options. We could do modus ponens with 3 and 4, and that gives us a contradiction with 5 and 6, and we're done. If we were, right, so because P, and if P then not Q, that gives us not Q, and we had Q from line 2, so we have a contradiction on lines 5 and 6. No need to do our step 5 subderivation. We went immediately to step 6. Now, we could have also done the modus tollens version, so we double negate 5 and then use 6 with 3 to give us modus tollens, and then we have a contradiction between 4 and 7. Either of these is perfectly adequate. The first one's shorter and easier, but I just want to reinforce this point that when you're inside of an indirect assumption, you can often complete the derivation in many different ways. There are many different routes to getting to a contradiction. Okay, so that's the last example. We show the conclusion, we make an assumption, conditional if we can, indirect otherwise. We bring in our premises, we apply our inference rules. If we get stuck, we do a subderivation, and we're always looking to box and cancel, and it might be any of CD, DD, or ID. At this point, in general, the assumption and the boxing and canceling method will match. So if you made a conditional assumption, you will probably finish with conditional derivation, and if you made an indirect assumption, you will probably finish with indirect derivation. Okay, so in the next video, I will do some more examples.